Alright class, welcome to the week 3 lab tool demo. This week we shift gears a little bit, so we step outside of the comfort zone of Windows that many of us are used to and step into also using, I guess we don't really step out of Windows completely because we are using Windows for part of the lab, but we step into the Linux environment to do some command line tools as well. And the virtual environment that we'll use for that is Remnux, which is made available through Lenny Zeltzer and his team, who are SANS affiliated. So the SANS Institute, he teaches the Forensic 610 course, Reverse Engineering Malware. Incredible course. Have gone through it myself, and this is just an incredible resource that they make available as a free distribution for anyone that wants to do command line based reverse engineering. So this is what you're seeing in front of us. This is Remnux, Reverse Engineering Malware Linux distribution. And what we're going to do is run through a few tools and see the functionality of some of these command line tools that are built into Remnux. So when you actually look at Remnux, there's not much there to it, right? So you go down to what is typically the start menu, and there's just not a lot there that's from the graphical side. That's because most of the Remnux tools are command line tools. Do make sure that you check out the cheat sheet here, which gives you a lot of good information about the different commands and exactly what is on this box. And certainly I encourage you to go there. That is on the desktop for you there. So what we're going to do is start out by just assessing a Windows executable. This is obviously not going to properly execute in a Linux environment, but we're going to start looking at several files there, or several executables and behaviors, and see exactly what the functionality is for this particular week's lab. So first and foremost, we go ahead and open up a command prompt, and we see that we are not at root for many of these commands. Many of the tools that we're going to be using, you are not required to be at root. Guess it doesn't really hurt to go ahead and actually be there, just in case something does come up. And the first set of tools that we're going to look at are really just the basis of examining suspicious Windows executable files. And that's always the big question: is at what point do you determine if a executable is in fact suspicious? And we base it off indicators, right? So there are multiple steps that we can take to get to the point to where we actually fully determine that we're dealing with malicious executable. And one of the tools that we can use to help us with that is one called PEScanner. It helps us assess if the file is malicious. It will pull out the details quickly to help us make our assessment. And that is the first one that we're going to go through and look at today. So what we'll do is in our desktop, much like our Windows VM, we also have an infected folder as well. So if you go out to your desktop, you'll see that there is this infected folder, and then under week 3, I got a DLL and a couple of DLLs and a couple of executables that we're going to look at this week. So simply, if we want to start finding out basic information about these particular executables, what we could do is just starting off by simply doing file, the file command, and then, for example, the Croker executable. Actually, I need to change my directory because I'm actually at root still. So I'll change my directory, and I am going to go to my week 3 folder and just do it the easy way. And come back, change directory, and we are in business. So now we're in file. And this just gives me a little bit of information about what we're dealing with. It is a executable file for Microsoft Windows. But now I want to run PEScanner against Croker. Okay, and running PEScanner actually, I'm going to get out of root. For some reason, I think it is actually messing me up here. So go back to command terminal. Okay, and we'll change directory. And we'll do PEScanner again. And most of the time when you're at root, that's when it's giving you most of the functionality. But in this particular instance, being at root, PEScanner is not jiving too well. So it runs, okay, and within PEScanner there's quite a bit of information that is actually made available to us. So we can actually look at our hash values, look if there's any languages, packers present, things of that nature. So that's PEScanner, and we can look at quite a bit of information there for this week's lab to answer those questions. And then also inside of PEScanner, you have built in the open source ClamAV antivirus as well. That can certainly be of assistance to us as well. In addition to looking at the packing, looking at the hashes and the AV, you also have what's called signature scans, which we'll look at here in just a few moments. But you also have these areas that give you an overview of suspicious inputs, and that's what's called our IAT alerts. Okay, that's our input address table, and that's basically info that's embedded in the header that'll include external DLLs and function that's needed for the overall functionality of that executable. The external dependencies are found in this IAT, this input address table, okay, that you see here. Now looking at the IAT, we can find external system calls, which we see here, get command line, get startup info, and make a guess of the functionality of the program. And for this particular program for Croaker, we can see there's quite a bit of different types of IAT alerts that we can then go out and maybe do some open source research on. Also, when we're under sections, we can also see that there is what's called entropy. So PEScanner shows us the sections. It looks for unusual names, and this is most useful with the entropy test. Okay, so when we look at the entropy test, the higher the entropy, because a question that comes up is what is the baseline, what is really kind of the signature entropy that we're looking for as a numerical value that would be suspicious. And entropy really just looks at how random the contents are. And so the more random the contents are on the executable, the more likely it is the section contains maybe compressed or encoded content. And this will more than likely want to unpack itself at some point, and this allows us to assess the likelihood that the program is packed. When we start looking at the packers again, we could bring that over to Windows environment and try to unpack it or do some open source research on the particular packer itself. So that's a little bit about PEScanner. Gives you quite a bit of information to look at there. PEScanner also will work with DLL files as well. So just like we invoked it and ran it against the exe, you can also run that against the DLL files the same way. One of the great things that when you do start running it against the DLLs is you do find yourself getting a little bit more information in return regarding signatures. So if we were to go back and run PEScanner against another one of the DLLs that we have in our folder this week, and I'm pretty sure that I misspelled it. That's what it is. There we go. And this just takes a second because it's doing a lot of processing in the background to give us such a robust output. One of the things that I wanted to make you aware of is, in addition to the IT alerts, the imports, you also have some additional information that you can pull down from this as well. And that is associated with what's called YARA. So looking at the DLLs in this particular instance, when we look at the signature scans, we would typically see here if there was anything that was showing that would be associated with YARA, if this particular DLL actually did contain the signatures that YARA would pick up. So what is YARA? So PEScanner uses signatures to allow us to further preview and detect suspicious code snippets. Okay, so it uses YARA, which allows you to define your own signatures, but also comes with predefined signatures as well. YARA signatures have detected in some instances that maybe it comes with unzipping or decompressing mechanisms, which is known as deflate. Again, that in and of itself is not necessarily malicious. We're not seeing any preview on this one, but just to give you a heads up, you might see that in some of your DLLs that you do examine or executables. Another thing to keep in mind also is looking for languages that might exist as well. And then the system calls, once again, make sure you are looking at those to check to see what those possibly are. If you're not going to run those inside of the Windows environment, again, open source research, Google could be your best friend there. Another interesting tool is one that's called Pew. It's spelled P-Y-E-W and pronounced Pew. And it is a command line hex editor, viewer, and disassembler. So Pew allows us to navigate and explore an executable. Okay, so let's say we want to run that against one of the executables that's in our folder this week, and we run Pew, and it again provides us a lot of good information. So we have our hex editor here on the right. Okay, and with Pew we are able to go out and imports section will show me all of the imports address table entries, which is nice. So I can actually do imports. It shows me a subset of those entries as well. Okay, so PEScanner only showed me a subset that we saw earlier. Pew shows me all the entries, a much more robust list. It's based on system calls. What are these capable of? You would cross-reference these with the MSDN, so Microsoft's database, and get some really good information on that. We can then run another command that's called URL. Okay, and it's going to show me that it's affiliated with a site that we can then go out and research to see what that's associated with. So a lot of good things that you can do there with Pew. Sometimes malware authors will conceal sensitive commands. What if that URL was some way obfuscated? Well, there is another command that we can invoke that's called XOR Search. Okay, and XOR Search allows us to kind of bypass the obfuscation that some of the malware authors may try to invoke. It basically finds strings that are obfuscated using common techniques. Okay, now you have to know what you're looking for though when you're doing XOR Search. You have to be able to identify and basically speak to what it is you're specifically looking for in XOR Search. And what I mean by that is, we'll change the directory here and show you this is another DLL. So we run XOR Search, and we run this against another DLL, but then I have to say what is it that I'm looking for. And so in this particular instance, if it's web traffic, okay, I'm going to do HTTP. You may want to do HTTPS as well, and it'll tell you what it finds. Okay, which is nice because this could potentially be obfuscated in instances where, again, the malware authors would have done so. So when you run the XOR search, this allows you to see what it is that's going on regarding, in this particular instance, URLs. And then from there, you don't have maybe necessarily an IP available, so you could actually research on the web and see exactly if there's any relationships to any type of malware. And you might find URLs there that you need to blacklist or further investigate. Now with XOR Search -s, this actually creates a file called hubert.dll XOR05, basically where it tried to decode every string with that specific key. Okay, and the key here is this 05. Okay, so what I can do is go out and run strings. And just do an output to use this program called Cite. It's a nice text viewer within Remnux. And actually what this is telling me is that it's already or it has not existed yet. So I actually already have this particular file saved in another directory, but wanting to show you exactly what this looks like by the command line, we'll go ahead and run that from the beginning. And we'll do Cite. Again, this is just the text viewer. Okay, and I just basically invoked the command to open up Cite, and what I'm looking at here in this particular output, I can start going through and using Cite, again, this text editor, to look at the content of the output. Okay, and what has happened here is a decoding of every string there. Okay, and as you can see here, some good information that is showing up here that was not present initially without using XOR search. So those are a few of the tools that I hope you guys will enjoy using this week for the command line for your labs this week. Let me know if you have any questions, and I hope you guys enjoy using Remnux. And do make sure that you take advantage of the Remnux cheat sheet there for additional functionality.